Good morning, everybody, and welcome to the homework helper for probability section 5. The very first section of this starts with a review of quadratic functions, and it asks us to do a few things. It wants us to find the x-intercepts, the y-intercepts, the line of symmetry, and the vertex of each of these quadratics. So there's a lot of steps that are involved in this, but luckily I'm here to guide you through it. First things first, we need to think about what exactly x and y intercepts are. When we have a Cartesian plane, x, y, wherever we cross the x-axis is of course going to be our x-intercept. But for quadratics, sometimes it'll cross it twice, right? We might get something like a shape like this. So there can be up to 2 x-intercepts. Remember, this is where y equals 0. For our y-intercept, it's a little bit easier. We will only have 1, and this is where x equals 0 for our y-intercept. And then vertex and line of symmetry we will figure out once we get it into vertex form, and we'll cross that bridge in just a second. But I want to start with the x and y-intercepts for some of these. So when I'm looking at this first problem here, x squared plus 8x minus 9, and it wants us to find the x and y-intercepts, I'm going to start with my y-intercept because it's just easier, because the y-intercept is where x equals 0. So all I have to do to find my y-intercept is plug in 0 for x. 0 squared is 0, 8 times 0 is 0, so this is just negative 9. So I know that the point 0, negative 9 is my y-intercept. Y-intercept, 0, negative 9. Beautiful. Okay, now to find my x-intercept, it's a little bit more work. To find the x-intercept, we need to figure out where y is 0. So 0 equals x squared plus 8x minus 9. So now I need to figure out the values of x that make this true. Now, you'll notice that the power is going to be x squared. We have the number of solutions based on the power on the x. So we're going to have 2 solutions. There's going to be 2 numbers that cause this to be true. What does that mean for us? How do we find that out? Well, the first thing we need to do is we need to factor our trinomial. So step 1 is factor our trinomial. And typically how we do this when we have an a of 1 is, I like the x method. We have 8, negative 9. We're looking for 2 numbers that multiply to negative 9 but add to 8. 2 numbers that multiply, there's 2 numbers that multiply and they equal negative 9, and those same 2 numbers, when we add them, equal 8. And so when I'm thinking about this, the numbers that make that true are going to be 9 and negative 1, right? Because 9 times a negative 1 would be negative 9, 9 plus a negative 1 would be 8. So 9, negative 1. Sweet. So I know that this now factors to be x plus 9, x minus 1. 0 equals. And so now what I have is I have two parentheses being multiplied by each other. This times this. If one of those is 0, then it would cause the whole thing to be 0. So this is where I get my 2 equations. I know either 0 equals x plus 9 or 0 equals x minus 1. And then from here I can find my values of x. Negative 9 equals x, or 1 equals x. So my 2 answers for my x-intercepts, my 2 answers are negative 9 and 0, and 1, 0. Those are going to be my 2 answers. Cool. Next, when we want to find the vertex, we have to convert this into vertex form. Converting into vertex form is a bit tricky. We have to do a thing called completing the square, but we've done this before. We'll do it again. So here we go. F of x equals x squared plus 8x minus 9. When I am trying to get this into vertex form, And remember, vertex, this might be important actually. Vertex form is of course f of x equals a times x minus h squared plus k, where hk is our vertex, a is our stretch. Okay, so we're trying to get it to look like this. So my first step in getting it to look like this is the first thing I'm going to do is I'm just going to ignore this -9. It's still there. I'm just going to pretend it's not there for the time being. I'm just going to look at my x squared and my x term. Okay. So now that I have my x squared and my x term, I'm going to try to create a trinomial here. X squared plus 8x plus something. Okay. What is the something I'm going to add there? I'm going to create the perfect square. So when I think about how I get that middle term, what I'm going to do here is I'm going to take this 8 and I'm going to divide it by 2, and then I'm going to square that number. So I'm going to take 8 divided by 2 and square it. That gives me x squared plus 8x. 8 divided by 2 is 4, squared is 16. And you might be thinking, Victor, why did you do that? You're a crazy person, and you're not exactly wrong. But the reason I did this is because look at what happens when I do the b divided by 2 squared. You know, if I were to then factor this, what two numbers add to 8 but multiply to 16? Well, 4 and 4, the same number. This is a perfect square. So this can simplify to be just x plus 4 times x plus 4, or to make it look like vertex form, we want the same binomial squared. So that's just going to be x plus 4 squared. And then now I have to keep in mind that I did all this funny business with this ignored number 9, right? I have this -9 over here, so there's really a -9 over here. But look at what happened here. I added this 8 over 2 squared. I can't just add numbers willy-nilly, right? I can't just add numbers without taking it from somewhere. So I actually need to subtract that 8 over 2 squared from that -9. I added it, I subtracted it on the same side of the equation, therefore it's a net change of 0. So here I still have that -9. Here I wrote it as a plus 16, I gotta write that as a minus 16, right? These are saying the same thing. So really, -9 minus 16 is minus 25, minus 25. I now actually have it in vertex form. F of x equals the quantity x plus 4 squared minus 25. I now know my vertex. My vertex is going to be, let's see if I'm running out of colors, but black is kind of a color. Okay, my vertex is minus h comma k. Whoops, that fell off the screen there. My vertex is minus h comma k. So my h here is 4, so minus h would be -4, and my k is -25. -25. I have found my vertex. And now the last thing that it wants me to find, is my line of symmetry. The line of symmetry, you have to think about what a parabola looks like. Here's our first parabola sketch. We have the vertex here, and so that line through the vertex is going to be your line of symmetry. So all we have to do is figure out what the x value of our vertex is. That's our line of symmetry. The x value of our vertex is -4, so line O symmetry is going to be the line x equals -4. There we go. That's all the information we need. That's all the information that was asked of us. A lot of steps to these. You should have touched a little bit on this at the end of Algebra 1. This is definitely some Algebra 2 content, so I expect it to be kind of a challenge. But there is one in-depth, step-by-step, rewatch, look at each step, go through one at a time to really master that. Let's go ahead and move on to the set piece. Set. Alright, let's do it this way. Alright, independence. We're going to be determining the independence of events, and they can sometimes be done by becoming familiar with the context in which the event occurs and the nature of the event. There are also some ways to determine independence of events based on equivalent probabilities. So if we have two events, A and B, and if they're independent, then the probability of A and B is going to be equal to the probability of A times the probability of B. Additionally, two events, A and B, are independent if the probability of A's that are B is equal to A of B over probability of B, and that's going to equal the probability of A. So we're going to use these two ways to determining the independence of events to see if these problems themselves are independent. So here we go. We got the probability of A and B is 3 over 5. The probability of A is 1/5. The probability of B is 3/10. So if this is true, I'm looking at my first possibility. The probability of A and B, that's right here. So 3/5 equals the probability of A, that's right here, times the probability of B, that's right there. Okay. Now, is this a true statement? Let's find out. So 3/5 equals 3/20. Is 3/5 the same thing as 3/20? Nope. These are not the same. So are they independent? No, I would say these are dependent. Okay. Do the same thing here. Probability of A is 1/5. So 1/5. Probability B is 1/3. And is that going to equal the probability of A and B? 1/6. Okay. So this is going to be 1/6 equals 1/15. No, doesn't work. Doesn't work for that one. Now, just to be sure, let's see if it works. Let's see. Actually, can we see if it works that way? No, we're good. We don't need that rule. It's just that first rule will guide us through all of this. So yeah, that's all you need to do is set up these equations, see if they're true. If they're not true, then we're going to say they're dependent. And if they are true, they're independent. All right. Final stage. Finding probabilities from a two-way table. Okay. So the following data represents the number of men and women passengers aboard the Titanic and whether or not they survived. Going back to this fun topic. All right. So the key things to think about here is when we're given probability like W, that means probability women. That would be the part 402 over the whole 1207. Now, when we go to something like this, okay, the probability of survivors who, well, it's kind of weird. The probability of survivors out of women. So we have to look at the total number of women for our denominator, 402, and the number of survivors who are women, 296, okay? Now for this one, it's probability that someone is a woman or a survivor, okay? So we can look at women or survivors. So that would be, here are the survivors, here are the women, okay? So we would look at these probabilities combined, so it would be 402 plus 442 out of the whole 1207, but we double counted, so we subtract 296, okay? So probability of all the women, probability of all the survivors, but we double counted this 292, you can see because I circled it twice, so we need to subtract 292, okay? Now just simplify that, okay? So on and so forth. This one, we have the and symbol, so men who did not survive. So that just means we're looking specifically at the men who did not survive. We are just looking at that joint frequency. So that's going to be 659 out of our total 1207. Okay. So again, it's just making sure you understand the terminology of what the probabilities are asking us. Those are the key things, right? We have these dependent clauses. We have our or statements. It says or, sometimes we write the or symbol as that, it's like a U, and we have our and statements. So dependent, and or, and or, and or. Say that 3 times fast. Dependent and or are the ones that we need to really know and know how to set up correctly. And there you go. Good luck with all of that.